In this course section, we're going to stick to the app on which we worked over the previous couple of sections, but in this course section, we're going to enhance it with animations. So we're going to make things move. And you will learn how you can add animations to widgets in Flutter, and you will learn that you can either add explicit or implicit animations. And of course, I will show you what the difference is and how these different animations are created. And we will therefore build a custom animation from the ground up, but you will also learn how you can use various built-in animation widgets to build and add animations with ease. Now, as mentioned, we're going to stick to the project on which we worked over the previous couple of sections. Therefore, attached you find my latest project snapshot of the lib folder, so you can simply drag and drop that lib folder into a new Flutter project. You also find my pubspec.yaml file attached, and you should make sure that you add Google Fonts, Transparent Image, and Flutter Riverpod to your project with their latest versions, which can differ from these versions here. But you should add these packages so that you're ready to go. And with that, we can dive right in. Now, we will start by adding an explicit animation, but of course, for that, you first of all must understand what the difference between explicit and implicit animations is. And in the end, the difference is that with explicit animation, you build and control the entire animation. You have detailed control over its configuration, whereas with implicit animations, Flutter controls the animation and does a lot of work for you. Therefore, with explicit animations, you have more control, but also more work to do, and therefore more complexity. And on the other hand, with implicit animations, you have less control, but therefore also less complexity to manage. And indeed, often you can avoid building your own custom animations. So often you can avoid explicit animations and instead use one of the many pre-built animation widgets offered by Flutter to make your life easier and add animations to widgets with ease. Now in this section we're going to see both, but as mentioned, we're going to start by adding an explicit animation. So let's add an explicit animation. And for that, I'll go to the categories screen where I have this grid view, where I display a grid of category items. So in the end, I'm talking about this screen here. I want to add a little animation to that screen that lets these category boxes, these category items, slide in from the bottom whenever we load this screen. So when we, for example, get to this screen from the favorites screen, or if we just started the app. And such a slide animation could be built by adding our own custom explicit animation to this categories screen. Now to do that, we first of all have to convert this categories screen class here to a stateful widget. And for that, we can right-click on stateless widget and choose refactor and choose convert to stateful widget. Because if you're adding an explicit animation to a widget, you must add it to the state object of that widget. So you must be working with a state object because behind the scenes, an animation sets the state and updates the UI all the time as long as the animation is playing, which is why it needs such a stateful widget so that it can update some state behind the scenes and re-execute the build method. That's the idea here. Now, with this changed, you can go to your state class, and here you first of all have to add something. And in there, you can now create a new property that could be called _animation controller. The name is up to you, but in this property, we are ultimately going to store a value of type animation controller. However, this animation controller can't be created here where the property is initialized. Instead, you should use initState for this. So you should add this initState method about which you already learned earlier in the course. And in this initState method, you can then create this animation controller. Nonetheless, this animation controller must be set before the build method executes. And to tell Dart that this property doesn't have a value initially when the class is created, but will have one before it's really needed, you can add a special keyword in front of animation controller, which we haven't used up to this point. You can use late, the late keyword. And this tells Dart that this in the end is a variable which will have a value as soon as it's being used the first time, but not yet when the class is created. So that there simply is a little timing difference between when this property is created technically and when it will have an initial value and when it will be needed for the first time. With late, you tell Dart that it will be fine. Once this property is used, it will have a value. Now, speaking of a value, you should still set the type of value that will eventually be stored in here after late before the property name. And the type here will be animation controller, which is a type built into Flutter. To be precise, it's a class provided by Flutter, and as you learned in this course already, every class brings its own type. Now we can initialize this animation controller in init state. So then it will be ready before build is executed, but as mentioned, not right away when the class is created. But that's fine because of late. So here in init state, we can now set animation controller equal to animation controller using that class provided by Flutter to create an object based on that class. And now this class's constructor function offers a bunch of configuration options here. And there is at least one option, vsync, which we must set. Now vsync wants a so-called ticker provider. In the end, this vsync parameter is responsible for making sure that this animation executes for every frame. So typically 60 times per second to overall provide a smooth animation. For this, it must be set equal to such a ticker provider, and this ticker provider is actually received by using another special feature offered by Dart, which we haven't used up to this point, and which, to be honest, you typically don't have to use that often, but you do need it here for explicit animations. You should add the with keyword here after extending this state. And that's another keyword built into Dart, a keyword which allows you to add a so-called mix in to a class, which you can think of another class being merged into this class behind the scenes and offering certain features to this class, therefore. And the class that should be merged in here is the single ticker provider state mix-in, which is provided by Flutter. And behind the scenes, this class, which we're merging into our class here, simply provides various features that are needed by Flutter's animation system. By the way, if you had multiple animation controllers and not just one, the right choice here would be the ticker provider state mix-in like this, but if you only have a single animation controller, it is recommended to use the single ticker provider state mix-in instead. Now with this added, the value for vsync should be set to this. So to this entire class, which now has this ticker thing merged into it, and therefore behind the scenes, this animation controller will be able to get this frame rate information which it needs to fire our animation once per frame. So for example, 60 times per second. That's what we're setting up here. Now, in addition to vsync, which is always required when creating an animation controller, you can also add a duration to control the duration of the animation you want to play. And for that here, you can create a duration object by using Flutter's duration class. And here I'll set my duration to, let's say, 300 milliseconds. And of course you can play around with that value to control how long this animation will play. So this animation where I want to slide up my grid items here. Now, besides the duration, you can also set a lower bound, for example to 0, and an upper bound. And with that, you will in the end control between which values Flutter will animate. And this might sound strange, but it's important to understand that with animations, you in the end always animate between two values. For example, 0 and 1. And then it's your job to translate these values into something that changes something on the screen. For example, you could be adding some margin or padding to a widget, and that margin or padding could be based on the current animation value, which is between these two boundaries. And the animation controller will automatically move between these boundaries during this duration. And if this is still a bit abstract, you will see it in action in just a second. By the way, these settings here, 0 and 1, are the defaults and don't need to be set, but you can of course also set them explicitly if you want to, or set them because you want to animate between different values, like 0 or 20. Again, it will depend on what you plan to change based on these values. So here I'll stick to these values and explicitly add them even though they would be the default. But now with that we have an animation controller which we can use to play the animation. However, that's not all we have to do. Besides now using this controller, which we'll do in a second, we also should add this pose method here, which is another method built into Flutter widgets, which is called automatically behind the scenes, but which you can override to then still call the parent widgets method behind the scenes, but to then also perform your own cleanup work. And here I'm using this pose to use my animation controller and call this pose on that. This makes sure that this animation controller is removed from the device memory once this widget here is removed, to make sure that we don't cause any memory overflows or anything like this. And now with that, we're ready to use this animation controller to actually change some values that will have a visual impact. So how can we now use this animation controller? Well, I mentioned that behind the scenes it would update the state and kind of re-execute the build method therefore. Now, technically that's not entirely correct though, because if it would do that, it would mean that everything in the build method is rebuilt and re-evaluated 60 times per second if you have a frame rate of 60 frames. And whilst you want to do that for the things you're animating, you might not want to do that for all the other things that might be on the screen. For this screen here, it actually doesn't matter, because here I do only return this grid view, which I do want to animate. There is nothing else here, but for other screens it might matter. So therefore, animated controller does actually not call build multiple times, but instead you can think of it as a timer or an interval running behind the scenes to which you can listen to then manually update parts of the UI. And you can listen and update parts of the UI by using another widget provided by Flutter, the Animated Builder widget. This Animated Builder widget wants an animation and a builder. Now, the animation is a listenable object, and as it turns out, our animation controller is such a listenable object. So we can pass our animation controller as a value for animation to Animated Builder. And behind the scenes, this will basically tell Animated Builder when it should call this builder function here. Because this function which we pass to builder, this function here, will then be executed for every tick of our animation. So for example, 60 times per second. And then inside of this function, you can update a widget's padding or margin or whichever value you want to animate. So for example, here I'll take my grid view like this and cut it and use that as a value for this function here. So as a return value returned by this function. Now in this function, you also get some arguments. You get a context and a widget. Now the context is something we know. The widget we get here is an extra widget, which we could add here on Animation Builder. We could add an extra child parameter here to set any widgets that maybe should be output as part of the animated content, but that should not be animated themselves. And this would allow you to improve the performance of an animation by making sure that not all the items that are part of the animated item are rebuilt and re-evaluated as long as the animation is running. And indeed, this is a feature which we can use here to actually set our grid view here as a child by cutting it again and setting it as a child. And by then adding a, let's say, padding widget here, which is then the actual widget that will be animated, which child is set to this child, which is the grid view. And therefore the grid view would technically be displayed inside of the padding, but it would not be rebuilt and re-evaluated 60 times per second. Only the padding widget would be rebuilt and re-evaluated that often. And from a performance perspective, that's of course preferable to re-executing everything that often. Now the padding widget also needs a padding value, and here I now want to set a value that's dynamically animated. And for this we can of course again use edge insets, but now here I'll use edge insets only to set the padding to the top, and this padding value should now be set dynamically. It should be set dynamically based on these bound values between which I'm animating. And the animation controller will start at a value of 0 and end after 300 milliseconds at a value of 1. Therefore, to animate my padding here, my top padding, I could set this equal to animation controller dot value, which gives me access to the current value, which will be between 0 and 1 as you learned, times 100, for example. Now we would animate up to a padding of 100, because initially animation controller value is 0, and 0 times 100 is 0. But at the end, after 300 milliseconds, we would have a value of 1 here, and therefore the padding would be 1. Now if I do that and save everything, we can therefore see, if I go to favorites and back, nothing happens. And the reason for that is that indeed out of the box, just by adding such an animation controller, the animation will not be played. To play it, you have to explicitly start it. And we can do this here in init state right after creating it. For this you can target the animation controller again, and then here you got various controls. For example, you can stop it with stop if you would want to pause it whilst it's playing, for example, because a user tapped some widget or anything like this. And you can also start it by calling forward. This will start the animation and play it to its end unless you stop it in between. You could also use repeat instead of forward so that it would repeat the animation and always restart it once it's done. But here I'll go for forward. And with that, if you save this and then restart this, you will see that indeed if I go to favorites and back, this animation plays and it slides down these items. But wait a second, slide down? I wanted to slide them up. Well, we simply have to adjust our logic down there in the animated builder. Currently, I'm animating from 0 to 100 here with this logic. To slide my items down, we should change this logic and, for example, set the padding to the top to 100 minus animation controller value times 100. This will initially be 0 and therefore will start at a padding to the top of 100. And by the end of the animation controller value will be 1, so this here will be 100. And 100 minus 100 will be 0, so therefore at the end of the animation, the padding to the top will be 0. And with that, it should indeed slide up. So if we save this, now this looks better. And now I got this animation as I switch to this screen. By the way, not if I come from the filters screen, because here this categories screen was never removed from the stack of screens. That's different with favorites, and the animation of course only restarts if the widget is re-added to the screen, because we started in init state, and init state is only executed when the widget is created. when we move to the filters screen, the categories screen is still on the stack and it's not recreated if we come back to it. It's just shown again. That's why we don't get the animation here, but why we do get it if we, for example, come back from the favorites screen. So that's how you can add explicit animations. By adding such an animation controller, configuring it, starting the animation, and then also controlling what should be animated, for example, the padding. And here, as mentioned, we're also using the performance optimization of putting the content that actually should only be part of the animation, but which should not be rebuilt because its values don't change, by putting that content into the separate child here so that it's included in the animated content but not rebuilt, which helps us with improving the application's performance. Now, this animation here works and doesn't look too bad, but we can also build it in a slightly different and typically better way. Instead of animating our padding like this here, we can also return a different value here in our builder. We can return a slide transition. And indeed, Flutter has many transition widgets built in. If you take a look, you, for example, also have a fade transition, you have a size transition to animate between two sizes for a widget, and a line transition to animate the position of a widget, a scale transition to scale a widget up or down, or, for example, a slide transition to animate the movement of a widget from one position to another, so to say. And for that, slide transition needs multiple parameters. For example, it needs the child that should be animated. In this case, it's still this child which we're outsourcing here, the grid view, so that this grid view is not unnecessarily re-evaluated. But that's the child that will be animated by slide transition in the end. Now, position also must be set, and that's actually not a number, but instead an animation that animates an offset. Now, what's that? Now, an animation in the end is what we get with help of animation controller. That's an animation in the end. An offset then is a special kind of value used by Flutter to describe the, well, amount of offset of an element from the actual position it would normally take. And to make this a bit clearer, let's simply start adding a value here. And the animation I will add is my animation controller, and on that controller you can call the built-in drive method. Now, this simply is a method that can be used to build an animation, as you can see, based on some other value. So in the end, it is a method that can be used to translate this animation between these two values, 0 and 1, to an animation between two other kinds of values. For example, between two offsets here, because here we need an animation over offsets, not an animation between two doubles, not an animation between 0 and 1. And drive simply allows us to translate our animation between 0 and 1 to an animation between two other values. For that, drive wants an animatable child. And such an animatable child can be built with Flutter's tween class. The tween class creates tween objects, and the name tween simply comes from the fact that this class and these objects are all about animating or describing the transition between, hence the name tween, two values. And for that, tween takes two values, as you might guess, begin and end. And now here we want to animate between two offsets because position wants an animation over offset values. Such an offset can be created with Flutter's offset class, and offset simply takes two doubles, two numbers with decimal places. The first number describes the offset on the x-axis and the second number on the y-axis. So here, where we're talking about sliding some element, we're basically saying how much to the right or left on the x-axis and how much to the top or bottom on the y-axis should we start. And here you can enter values for both x and y between 0 and 1. And 0 simply means that there is no offset, and 1 means that there is an offset by 100% in the end. And here I want no offset on the x-axis initially, but I want some offset, let's say 30% offset on the y-axis, so that the content is pushed 30% down. And this can be a constant value, because even though we're going to animate, the starting point is constant. And the same is true for the end point. And here I want to have an offset of 0, 0, because I want to end at the actual position my grid view would normally have. So now these are the two values between which we want to animate, and now Flutter will figure out how to translate this animation between 0 and 1 to this translation between these two values. That is what Drive does in conjunction with Tween. And with that, if we now save this and reload, we will see that we again get a sliding animation, but now actually, thanks to us using slide transition, this animation behind the scenes is a bit more optimized, and it also gives us some extra features and capabilities. So which extra features do we get by using this way of animating the slide transition? Well, on this tween, we can call the animate method. And animate also returns an animation. Therefore, we can indeed replace animation controller drive with tween animate, since animate returns such an animation over an offset, which is exactly what position wants. But now animate takes an argument which we can use to get more control over how the animation is played back. To be precise, we can pass in a curved animation here, another object created with help of another class provided by Flutter. Now, curved animation in the end is a configuration object for creating such an animation with help of this animate method here. Curved animation then takes a parent, which is nothing else than our animation controller, so the thing that controls the animation, and it then takes a curve. And the curve here wants a curve value, but no worries, here you don't have to create one yourselves. Instead, there is a curves object or a curves class built into Flutter with a bunch of predefined animation curves. And these curves simply control how the transition between the begin and end state will be spread over the available animation time. So that we, for example, don't have a linear animation, but one where we start slow and end slow. So that we have some acceleration in the middle, but we end smoothly and start smoothly. And you can simply play around with these different curves to give your animations a more natural feel. That's the idea behind setting curves, and that's in the end the idea behind calling animate here and passing such a curved animation configuration object. It simply gives us more control over how the animation feels. If we save this and reload, you might see that now the animation looks a bit more natural, even though the difference, of course, is subtle. But that's another way of explicitly setting and controlling an animation, and you can, of course, now use this knowledge to animate all kinds of things in your Flutter app. But as you will learn over the next lectures, you often can also use implicit animations, which can make your life easier. Because with explicit animations, as you can see, you have quite a lot of setup work to do. With implicit animations, as you will see, you will have much less work to do. So let's take a look at those. So now that we covered explicit animations, let's dive into implicit animations. And implicit animations are all about using pre-built widgets offered by Flutter that can be used to add animations to certain areas of your app. And for that, attached you also find a link to the Flutter documentation to a page that lists some of the animated widgets offered by Flutter that can be used to add such implicit animations. You'll see an example for one such animated widgets over the next minutes, but you can also take a look at this list here to find more widgets that could be helpful to you. Now in this app here, I want to add an implicit animation in the meal details Dart file, so on the meal details screen. There we have this icon button in the app bar, which we use to mark a meal as a favorite or not. So in the end, this button here. And now I want to add a little animation to this button so that whenever we click this button and we change this icon, we also animate the icon to, for example, give it a spin and rotate it as it changes. And whilst we could add this functionality with an explicit animation with our own animation controller, it's even easier to add this kind of animation by using an implicit animation, so by using a pre-built widget offered by Flutter. And indeed, for many animations you might want to perform, pre-built widgets are often the better choice. So here for this meal details screen, for animating this icon here, whenever the favorite status changes, we can go to this icon parameter. So we really only want to go to the place that should be animated. I don't want to animate the entire button if it's really just the icon that I want to animate, because the event listener here can't really be animated, it's not visible. So I'm going to this icon here, and here as a value for icon, instead of setting this icon here as a value, we can set animated switcher as a value. And that is a widget provided by Flutter, which allows us to animate the transition from one widget to another. So from this star icon to this star border icon, for example. By the way, I can't use animated switcher here instead of icon, because animated switcher in the end is a widget, and inside of this icon widget here, Flutter wants an icon data value. Icon, on the other hand, wants a widget, so therefore here I can use animated switcher. But how does animated switcher work now? Well, it has a couple of parameters that we can set. For example, the duration of the animation, but also the child. And the child in the end should be our icon here. So we can paste this in here, because that's the child which we want to animate. Now we also have to add a duration here, of course. And for the duration, you can create such a duration object, and it's up to you which duration you want to set. Here I'll set a duration of 300 milliseconds again, but you can of course play around with that value. Now with that, that's a good start, but you will see that if you save this and restart the app, and you then go to such a meal, nothing will change here. There is no animation of this icon. Because even though we set a duration and the widget that should be animated, we haven't given animated switcher any information regarding which animation it should play. What should it do with that child? Well, that's the part which we'll add now. Animated switcher also takes a so-called transition builder. And transition builder wants a function that receives a widget and an animation. So therefore here we can add such a function. And as mentioned, here we get a widget and an animation. So I'll name the widget child and the animation, though since this here is your function, these parameter names are also up to you. And these parameter values here will be provided by Flutter. That's really important. You don't need to create an animation manually here. Instead, the animated switcher will do this for you behind the scenes. It will create the animation and start the animation. And it will start the animation whenever the child changes. So it will automatically detect this and play the animation as the child updates. And that's why it's an implicit animation. You don't need to worry about creating or starting or stopping or configuring the animation. That will all be done for you. That being said though, this function which you pass to Transition Builder also must return something which must be defined by you. It must return a widget, but it shouldn't return any kind of widget, but instead it should return one of these transition widgets, which I already mentioned earlier in this section, like fade transition or size transition, because these widgets, these transition widgets, then describe how you want to animate. So with animated switcher, we say that we want to animate whenever the child widget updates or changes. And in the transition builder, we now return how we want to animate. And here I'll return a rotation transition widget, which will rotate this child widget whenever it changes. So it will give it a spin. Now for that, it wants a turns value, and turns is not a number like 3, but instead an animation. Now thankfully here we get an animation automatically. So we can use this animation here. With that, we're almost done. But rotation transition also takes a child. And that in turn wants a widget. The widget that will receive this rotation animation. And that should be this child here, which in the end is this child. And yeah, I know, that's a lot of children. But in the end, it's this child here, which we set on animated switcher, which will control when this animation switcher activates and plays its transition. It's also this child which is provided by animated switcher to this transition builder through this first argument here. So this child here is whatever you set as a child here. And it's now this child which I want to set as a child for rotation transition so that the rotation animation is played on this child, so on this child in the end. So that's how all these children here are working together. And with that, finally, we got all the setup we need to animate this icon. And of course, here I still took some time to explain this, so it took us some time to build this. But of course, that's the case because you're currently learning it. If you take a look at this code, it should be easy to see that this is much less code than you had to write with the explicit animation. And that's why implicit animations often are the better choice. Now with that, let's save it and let's see whether it works though. If I go back here to Emil and I click this star, still nothing happens here. And the reason for that is that at the moment, with this code here, Flutter can't really detect whether anything changed. Because sure, I'm swapping the icon data inside of my icon, but it's technically still an icon widget and therefore an icon element that is visible on the screen. And Flutter therefore doesn't see any difference. It doesn't explore the detailed data stored in this icon. It just sees that it was an icon widget before and that it's now still an icon widget. So to make sure that Flutter is aware of this change, we should add a key to our icon here. And you learned about keys earlier in the course. They are always useful if you need to differentiate between two widgets that are of the same type, but got different data attached to them. And here we must add a key because the animated switcher will take that key into account to find out if we technically have a different widget than before, even though the type might be the same. And the key I will add here is a value key, which is favorite. And therefore it will indeed change between true and false, and Flutter will therefore see that something changed here and will then trigger this animation. So now with the key added here, if we restart this and go here, now we see an animation. And of course here we got a pretty wild animation because we're using the default animation between 0 and 1 as a turns value here. So we're in the end giving this star a full turn here, which looks rather wild. To change this, if we're not happy with this kind of animation, we could replace the animation we pass as a value 2 turns with a tween about which you also learned before and which you can also use in the context of implicit animations, because the whole idea behind a tween really just is that it gives you more control over between which values you want to animate. And here we could then, for example, create a tween where we want to begin at 0.5 and end at 1. And then again, Flutter would take care of translating its animation between 0 and 1 to an animation between 0.5 and 1. You now just have to call animate here, because otherwise you just got a tween, and what you actually need is an animation, and animate returns such an animation. Now animate then needs a parent, and previously that was the animation controller, but in the end, an animation controller is just an animation configuration object, and the same is true for this animation here. So you can simply pass this animation here as a value to animate. Now the only remaining problem here is that by default, Dart infers this to be an animation of type num, so a mixed set of numbers, doubles and integers mixed. And one way of working around this is to set this to a double by using 1.0 instead of 1, because otherwise this is inferred as an integer. An alternative would be to take advantage of the fact that tween is actually a generic type, and by explicitly telling it that the values should be treated as doubles. So either approach works, but with that we now changed the values between which Flutter will play an animation. And if we do that, we will therefore see that now this is a bit less wild. And of course you can still change this a bit more and, for example, animate between 0.8 and 1 to reduce this effect even more. Like this. It's really up to you what you want to animate here, but with that I think this looks quite nice, and this is how you can add an implicit animation, simply by using animated switcher or one of the many other animated widgets provided by Flutter. The difference between those widgets and animated switcher in the end mostly is that animated switcher only cares about the fact that you're transitioning between two values, and then you get full control over how to transition, whereas most of these other widgets are already focused on one specific kind of animation that will be played. For example, animated crossfade, which will simply fade between two different widgets instead of allowing you to decide which transition should be played. As always, it is simply best if you do dive into the documentation here as well, and you simply play around with these different widgets. Now, to conclude this section, there's one last animation which I want to perform, and that's an animation across multiple screens. When I select a meal here on this meals list screen, and we then transition to this meal detail screen, I'd like to animate this image so that it slides from this screen to the next screen. And whilst this might sound super fancy and complex, it actually, thankfully, isn't. Because Flutter has built-in support for animating widgets across multiple screens. And for that here, we can go to the meals Dart file, where I have this list of meals, and then actually to the meal item, because that is where I do have the image of my meal, here. And we now have to wrap this image, so in this case this fade in image widget, which is responsible for outputting the final image, with another widget. And that other widget here is the so-called hero widget, another widget built into Flutter. And whilst the name might be strange, this simply is a widget that exists to animate widgets across different screens typically. For that, hero needs a child, which is the widget that should be animated, but in addition it also needs a tag, which behind the scenes will be used for identifying a widget on this screen and on the target screen. And here I'll give this a tag of meal.id. It should be a tag that is unique per widget. And of course here I have multiple meals and multiple images, So therefore, every image should get its own tag when wrapped in hero, and the ID is unique per meal and therefore is the perfect tag per image. So that's the first step. We wrap the widget that should be animated, and you're not limited to images, by the way, though images are a common case. But you wrap that widget that should be animated with hero and give it a tag. And now you have to go to the place where you want to animate to. And of course, there must be a logical connection between these two places. For example, here we're on the screen where we're coming from, and now I'm going to the screen where we're going to, the meal details screen. And here in this meal details screen, you have to find the same widget to which you want to animate. So in my case here, this image. And it does not matter that this is now not a fade-in image, but a network image. The only important thing is that it's generally the same content, and that will be the case here. And now you wrap this widget here with hero as well. So I'm wrapping my image network with hero. And you have to give it exactly the same tag. So again, meal ID here. Because that's important for Flutter to identify the widget on both the start and the target screen. That's all you have to do. If you now save this and restart, you will see that if you go to this list of meals and you tap a meal, this image now animates between the screens, forth and back. And that, of course, makes this animation look a bit nicer than it did before. And as you saw, adding this is really simple. And that's it for this course section. In this course section, you learned how to add animations, and you learned that there are explicit and implicit animations. And you did learn how to set up your own explicit animations by creating and initializing such an animation controller, which, as the name suggests, configures and controls an animation, which you then have to start manually, and which you then can use in your widget tree to animate whatever you want to animate with help of Animated Builder. Here, for example, we animated some padding or later a slide transition, where we even used some animation data, the animation value to be precise, and translated it to different start and end values with help of tween. We even fine-tuned the animation duration distribution by adding such a curve configuration. That's how you can add an explicit animation, and as you can see, this of course gives you a lot of control and power, but it also increases the complexity, of course. And as you also learned, often it might not be needed. Because here in the meal details screen, we then used Animated Switcher to switch between two different widgets with help of a key being set on the widgets, and we played a rotation transition by just adding this code here, which is of course less code than for the explicit animation. Last but not least, you also learned about this hero widget, which can be used to easily animate a widget across different screens. Here from meal item, which is part of the meals screen, to meal details, where we also added such a hero widget. And that's how you can add animations to Flutter apps. As mentioned, definitely also take a look at the official documentation to learn more about all these different pre-built implicit animation widgets, and possibly also to learn more about animations in general if you want to. But with this section, you now got the basics down and you now know how you can animate widgets in your apps.